It says two solid spheres of the same volume. So let's draw that. Here's one sphere. Here's another sphere, and they've got the same volume. Okay. But one made of iron and the other of lead. So we'll say that this one here is made of iron, and this one here is made of lead. Okay. Are each suspended by strings. So let's draw that. Suspended by strings. Okay. And are submerged in a tank of water. Note that the density of lead is greater than that of iron. So, they're both submerged in a tank of water. So this is water. And the density of lead, this one here, is greater than that of iron. So let's say the density is the symbol for density of lead is bigger than, greater than the density of iron. Which of the following statements is correct? And then we've got a whole list of options here, talking about the buoyant force or the weight. So let's have a look at the weight and the buoyant forces, the two forces that are acting on these spheres. The buoyant force is the one that pushes these balls upwards, and it's from the water. Okay, so the buoyant force, FB, is calculated by the density of the fluid times the volume of the ball times gravity, and that's for both of them, FB. So both of them have the same density, because the density of water is always about 1,000. They both have the same volume, V, and G in both cases is 9.8. So they should both have the same buoyancy force. Okay? So buoyancy force for both are the same. Let's talk about the weight. The weight is the downward force, otherwise known as the force of gravity. Okay? The force of gravity we calculate by mass times gravity. But remember that mass can be calculated by doing density of the object times the volume of the object. So really, the force of gravity is calculated by the density of the object times the volume of the object times by gravity. So look how similar these two look. They both forces equal the density times the volume times the gravity. The only difference is this density for the weight, this is the weight, this density is the density of the object, whereas this density is the density of the water. Okay, let's have a look. The gravity of both is 9.8. The volume of both is both V. But what about the density of both? Is the density the same? No, the density of lead is bigger than the density of iron. So this force of weight should be much bigger than this one. A ball with a density of 0.94 times 10 to the 3 kilograms. So let's draw that and add that to our notes. So it said here a ball, and the density of this ball, the density of the object, is 0.940 times 10 to the 3 kilograms per meters cubed. Then it says a density of this and a volume of 1.4 times 10 to the minus 2. So this ball that we've drawn here has a volume that is equal to 1.4 times 10 to the minus 2 meters cubed. Next. Is placed in a fluid with a density of 0.87 times 10 to the 3. So this fluid, not water, because water is 1,000. This fluid has a density of 0.87. So let's draw that. So this ball is in a fluid, unknown fluid, and the density of this fluid is 0.870 times 10 to the 3 kilograms per meters cubed. Question: does the ball sink or float? Okay, so that's the first question. Does the ball sink or does the ball float? In order to know if it sinks or floats, we need to see what is the buoyant force and what is the weight. And then if the weight is bigger, it will sink. And if the buoyancy force is bigger, it will float. So we need to see these two, what they are, and then which one is bigger. So FB, buoyancy force, is calculated by the density of the fluid times the volume of the ball times G. G is 9.8. The volume of the ball is given here, and the density of the fluid is given here. So don't get your densities mixed up. Buoyancy force uses the density of the fluid. To calculate Fg, as we saw previously, it's mass times gravity, or density of the object times volume times gravity. So again, gravity is 9.8. The volume, we get it from the same place. And the density of the object this time, we're going to use this density here, the density of the object. And we'll put that in here. And we can see that the gravity, the weight, will be a bigger number based on the density. This will be a bigger force. So because the weight, Fg, is bigger than the buoyancy, Fb is here, and Fg, because Fg is greater than Fb, it will go down, it will sink.